So hi guys, we are back again, and and as always, we are trying to better understand and teach you how the linear regression works. So we are comparing here gradient descent and the normal equation. Basically, we will fit a line with normal equation, finding the best parameters, and then we will not at this time we will not use the scikit-learn library. We will just use math to find the best parameters through gradient descent.
The only library that you're going to use a lot, two libraries, is basically matplotlib to plot our graphs, and also NumPy because NumPy makes things a lot easier.
Exactly. So we will use a data set that I create searching in the internet if the house prices for their house size. And what we want to predict is exactly the house values. So the first thing that I did was to import this library from Google Colab so I could upload the file that was in my computer that has this name dataset.csv. And then I uploaded here as this name, this variable name, house data. So my house data is this data set CSV. That's our data set that we're going to work in this video. So X is equal the house size and Y is our price, our target value that we want. So we follow the same step by step to find our normal equation. Did we do that column vector of ones, distant shape of y, we concatenate.
Just the same that we did in the last two videos, just to find the best values possible for the parameters that we have.
Exactly. And then here I'm going to do a new code that is just to help me to plot my line in this video.
You guys can check it by yourself because you're going to put this notebook in the description of the video.
Exactly. So use this function in space that creates evenly spaced numbers in an interval. So my interval is the minimal value of x, that is 704, and the maximum value. And I will plot it like 1,000, 1,000, I don't know, yeah, 1,000 times.
Yes.
And I will create the a plot that we will use to plot our data. So and the line samples will have all the possible values of x. So it's going to be a line. It's like let me use it. I have the y-axis, x-axis, and then my link space, these line samples, will be exactly one line, as it has all the possible values of x. And when and then my y plot will be a matrix multiplication between the a plot and our theta. So this will show our already line, best line for
our perfect situation.
Yeah. And I will create here a theta descent. This theta here is the theta that we find using normal equation. And this theta descent is the one that we will try to find using gradient descent.
Iterations.
Yeah. I initialize a random value. I put a value next to the one that we find using normal equation, and to better fit the
and to be more quicker either.
Yeah. So
but you guys can try by yourself at home using other values.
I did the max iteration of 200, and my learning rate will be this alpha here.
And this learning rate is something that's really variable. You have to test a lot of values until you find one that better fit in your data set.
Exactly. And then,
but in practice, people use 0.001.
Normally. Yeah. So The name of this one is batch gradient descent because we use all our data at once to upload one time the line, the parameter. So the number of rows is the shape, is the number of rows of A.
Yes.
That is our X. And we do two for loops in order to upload our theta values. And we see here that y descent is the multiplication of our rows by theta descent. That is x, rows is x, right? All the value of x versus theta. And our y true, that's the value that we have already found, is upper down here. Oh, this is our data. And then I will always print the values. This was the value that we found. A and B ideal are the values that we found using the normal equation. And this one we will update until with the best one possible.
And it's important to understand that this is basically what scikit-learn does, but we did that without scikit-learn, like hard coding, so that you can see how the interaction code can get more accurate and comparing with normal equation. So scikit-learn does all this coding for you with basically 2 lines.
Yeah.
But it's nice for you to
know how it works.
Yes.
Yeah. So our E here is our cost function, error function. That is our hx.
That's our prediction.
Yeah. Plus the y true, that's the true value. Is that function that we saw? That's a h of x. Oh my, I'm sorry. H of x is equal theta
0 x0 plus theta 1 x1.
Theta 1 x1.
Yes, x0 is equals to 1. But,
and this part here is just showing our difference between one and the other. Then we multiply. We found the gradient theta also here. That's going to be our error versus the rows that are our values of x. Then we find the mean of this error, and also the mean of the error, the original error, and our vector of the gradient descent is going to be our gradient descent theta 1, our gradient descent theta 2 divided by the size of our number of rows. Yeah. And then here we will update the values of theta.
And now it's the magic. We plot those values
just to see how it
and you can see how it's getting always better. So this is the red line is the normal equation that always will show us the best solution possible for the data set. And the green one is our bet. We tried a random number, remember, the first time. And what we want to see is the green line getting closer each interaction to the red one.
Exactly.
That's what's supposed to happen, and that's what happens.
It's exactly what is happening. We can see here the A descent and B descent going down to try to fit into here.
Yes.
And A descent is the theta 0 and B descent is theta 1. So goes
closer
down.
and closer and closer.
This means that we are making our error lower.
Yes.
And until that.
Yeah, basically already fitting. Oh, see, in this is important to say that in this circumstance here, it's already very good prediction. Hands down here.
Yeah.
Like, even this is kind of good prediction. But as we saw in the first 2 examples, the tendency is that it gets closer and closer until a point that's basically the same.
Yeah.
The same line.
And that's it.
Yeah, yeah.
We
It's
did.
basically already the same line.
And with this, we finish our
Series.
of linear regression videos.
Yeah, it was fun.
I hope you guys have enjoyed it, and like and share it with your friends, and comments, talk with us.
Bye bye. See you.